kind of loosely based on the F-22 or Su-57 designs. Got my air intakes, some overpowered rocket engine, small stealth profile, with the exception of these. These are fuel tanks. I found the only issue I had was extended range, so I'll show that off as well, but I've got decouplers on there for dropping them. Equipped with an ejection pod for the nose, so it can eject even at supersonic speeds. Yeah, let's show it off real quick. And alright, so just getting everything ready. So what I'll be doing to show this off the way I wanted to show it off is I will be flying over to this hill, kind of over here. I'll point at it in a sec. I will drop my reserve fuel tanks, and I will show you max speed, which I should be able to achieve pretty quickly actually. And then I will boom my way through the mountain range, and then I will eject. And that should be the demo. You can see, oh, my computer's off. That's why that's fighting me so hard. So I was flight without a computer, pretty decently stable, all things considered. I really should have noticed that that wasn't turned on. So there are a couple problems with the fuel tanks. One is larger cross-sectional area, 2 is drag, 3 is weight. None of which are ideal for this aircraft's design, but those 2 small pods do double the fuel reserve. So the idea would be to get close-ish to the engagement zone, drop the fuel, just like they still do it with some craft like the F-15s and stuff. I'll go ahead and drop those here. Watch them drop. None of that explosion was our craft, that's just those 2 colliding together. Show the max speed here, which is somewhere around 14.5 or 1.4.5 kilometers per second. And that's before the thing starts to overheat. So you'll see that should be Mach 4 to 5 somewhere there. It's a rough estimate, I'm just using 300 meters per second. The issue with doing that is, of course, as these temperatures increase, the speed of sound increases. So that's a fun bit of trivia for you. The higher your Mach number, the harder it is to increase it. And that'll be the max speed, which again is about 1.4 kilometers per second. You can see I'm able to withstand some pretty harsh G-force here. I think I'm actually too high to get good control surfaces. I think that's why I'm slipping around. So as we come back down here, I should regain some mobility. We're just relying on thrust vectoring, and that can be challenging with the roll. But yeah, I mean, we're able to hit in excess of 15 Gs. So the problem, very reminiscent to the real F-22, is not what G-force can the plane survive, but how many can the pilot. So what I was saying about Mach number, just to wrap that up, Mach number is dependent, or speed of sound is dependent on temperature, and the velocity, as velocity increases, temperature increases. As temperature increases, Mach number decreases. As velocity increases, Mach number increases. So you get this weird dynamic where increasing velocity will make it'll reduce your Mach number, but not as much as it increases your Mach number. If that makes sense. So it's a rough estimate. I think we are pretty close to Mach 4 or 5, though, if I had to guess. Yeah, actually, the 15. Yeah, very close there. So I'll show off how maneuverable it is. Just kind of get lower our radar profile. This is something you can actually expect with real jets, too, is just to get low into valleys and canyons to reduce radar profile. Not so good once the enemy's trying to acquire a lock. You'll want to be up in the sun. But flying at high altitude is nowhere near as fun as moving through this mountain range. So here we go. I'm going to kind of reenact some of Top Gun 2 with this flight. see, we're able to boom up to supersonic pretty quick, even when we lose it through the high G-force. And we're able to maneuver very easily at these incredibly high G-forces. High speeds, which is very fun. I am quite proud with how this one turned out, and it's just so much fun to cruise through these mountain ranges at very high speed. I really want to do a cockpit view fly through at some point, but to play it safe, I'm just going to do it this way for now, to show it off. I will say one of the things, an interesting design flaw on it, is that it actually doesn't maneuver very well at low speed. That's kind of intentional, because if it maneuvers well at low speed, it will probably over-maneuver at high speed, and you'll end up tearing the thing apart whenever you try and make a turn, which is not the goal. So you see, whenever I slow down super hard, it actually doesn't quite turn as well. The other thing is, of course, high altitude, you lose your surface area controls, and so you have to rely on thrust vectoring, which is fine, it works, but rolling, I found, can be very uncomfortable. Alright, so that is a little stealth fighter jet here, kind of demo there. I'll quickly show off the ejector seat, which the only issue I've found is if I eject at too high of an altitude, or at too high of a speed, you can run into issues with it returning so fast that the chutes can't deploy. So I'm going to try and give it a little bit of a demo here. So let's see. Yeah, to slow it down. We'll tell the computer to follow a retrograde. That should give us a little more drag, and once we're clear of our jet, which I think we are. I didn't quite see where that went. I'm a little nervous about it. Anyways, speed this up. Whoops, somewhere over there. Maybe it veered off. There you go. This is a very, very fun aircraft. Anyways, hope y'all enjoyed. See y'all in the next one.